Plate tectonics for kids. In this video, we're going to tell you about something called plate tectonics. It sounds complicated and super science-y, but it's actually pretty simple once you know what it is. But first, stop what you're doing. Sit totally still. Can you feel the earth moving under your feet? No, you probably can't. But guess what? The earth is always moving beneath us. It moves and shifts really, really slowly. Of course, as you know, every once in a while, there's an earthquake somewhere. And when that happens, you actually can feel the earth moving. If you've never been in an earthquake, take a minute to think about what that might feel like. Earthquakes occur when the earth beneath our feet moves or shifts a lot, really quickly and all of a sudden. But earthquakes like that, the dangerous ones that we can feel, are rare. Most of the time, the land all over the world, the land that we walk on, is moving very slowly. So slowly that nobody on land can feel it. It moves between 1 and 6 inches per year and takes millions of years to notice it. The slow movement is caused by plate tectonics. So what are the plates and what are the tectonics? The word tectonics is actually from the ancient Greek word meaning pertaining to building. So when we talk about plate tectonics, we are literally talking about the way the earth was built. As you might have already learned, the earth is made up of several layers that go all the way down to its core. The top layer of the earth that actually moves is called the lithosphere. That layer consists of the earth's crust and part of the upper mantle, and it moves in big pieces of land called tectonic plates. They move because below them is a layer called the asthenosphere. The asthenosphere layer is basically liquid-like molten rock that moves around deep, deep below the Earth's surface and is all squishy like lava. The rock is molten or in liquid form because the center of the Earth itself is really, really hot and radiates that heat upwards. So the tectonic plates we just described are sitting on top of that molten rock in the asthenosphere. That's what causes them to move and shift. Think of it as if the plates were giant ice cubes floating in a huge glass of water. These plates that sit closer to the surface are in fact huge, some of them covering entire continents, and they're made up of major plates and minor plates. Check out this map. Here, you can see all the plates on Earth. As you can see, there are 7 major plates and 10 minor ones. The first thing you may notice is that the major plates are kind of aligned with the continents. That's not a coincidence. The continents on Earth were actually formed due to the movement of these plates over millions and millions of years. Think of the Earth as a giant jigsaw puzzle, made up of pieces that are basically parts of these major plates. But these plates are just a little bit bigger than your average jigsaw puzzle piece. A puzzle piece might be a half an inch thick. Well, these plates go down an amazing 62 miles into the Earth. If you had a car that could drive down into the Earth, it would take an hour at highway speeds to get to the bottom of a typical plate. And there's not just one kind of plate either. Plates are divided into 2 kinds, oceanic and continental. Oceanic plates are made from crust called sima that exists below the oceans. Sima gets its name because it's made from silicon and magnesium. Continental plates exist mainly below land, and they're made up of silicon and aluminum, and are therefore known as Sial. Tectonic plates move mostly at the places where they meet, at the boundary of 2 plates, and there are different kinds of boundaries: convergent, divergent, and transform. Let's explain. Imagine you have 2 big textbooks. You're holding one and your friend is holding the other. Now let's pretend those textbooks are the plates under the earth. If you and your friend push those textbooks up against each other really hard, one book might be forced under the other. That's a convergent boundary. So in the case of the plates under the earth, when you have a convergent boundary, one plate slides under the other in a process called subduction. When that happens, it forms mountains and volcanoes over a long period of time. Earthquakes can also happen where these two landmasses meet. Examples of convergent boundaries are Mount Everest and the Mariana Trench, which is deep in the ocean. Now, imagine those two textbooks again, but instead of pushing them together, you and your friend pull them away from each other. That's what happens when you have divergent boundaries. The area of land where this occurs is called a rift. And in those places, you might find giant rift valleys. Examples include the East African Rift Valley, the Galapagos Rise, and the Mid-Atlantic Ridge. Back to our textbooks. This time, imagine you and your friend put those textbooks against each other and rub them together up and down in a lateral motion. That's what a transform boundary is like. This type of boundary is more likely to create earthquakes. Examples of transform boundaries include the San Andreas Fault in California and the Alpine Fault of New Zealand. All this shifting and movement is how all the different types of terrains on Earth were formed, and the continents themselves. Believe it or not, over 250 million years ago, all the different continents on Earth were actually just one giant landmass called Pangaea. Over millions and millions of years, the continents of the Earth formed due to this tectonic plate activity, which moved the Earth's crust around. These days, scientists are using GPS technology to track the way the Earth's crust is moving. They hope to be able to use this technology to predict earthquakes and where they might occur. All of this talk of movement might make you feel nervous about how steady the ground is beneath your feet. But rest easy. There is at least 62 miles of Earth crust under your feet. Definitely enough to support you and your friends, and even your dog. Thanks for following Clarendon Learning. Be sure to subscribe. For more free resources, check us out at clarendonlearning.org.